Hi mathematicians, we're going to finish 2.6 with the intermediate value theorem, which is a really important theorem in math and calculus. Okay, and so basically what it's saying is that suppose f is continuous on closed interval AB and L is strictly between f of A and f of B. Then there exists a C such that f of C equals L. Okay, and I guess I should say that C where C is between A and B. Get rid of that one. Right? So suppose f is continuous on a closed interval AB and L is between these two outputs. Then there exists a C such that f of C equals L, where C is between these two. So let's look at what I'm saying graphically. So here I have my f of x here, and I have my closed interval AB, where we're continuous between, and this is my f of A, and this is my f of B. And I have some value L here, and as you can see, L is between my f of B and my f of A, right? It's greater than f of A, it's less than f of B. So what the intermediate value theorem says is that if there's some value L and it's between f of A and f of B, then there exists, this means there exists in math terms, there exists a C such that f of C equals L. Okay, so let's go ahead and use this for a second. And so this would be problems like 65 through 68. And it says use the intermediate value theorem. Intermediate value theorem to show the following equations have a solution on the given interval. Have a solution on a given interval. Okay. And so part B and part C are graphing. You can graph on Desmos. I should probably show you how to do that at some point. But let's suppose we have this 2x to the third plus x minus 2 equals 0. And we're given the interval -1 to 1. And we're going to use the intermediate value theorem to show that the following equations have a solution on the given interval. Okay, so let's look. I'm going to define this as f of x because it's easier for me. And so let's do the f of -1. And so we get 2 times -1 to the third plus -1 minus 2 equals 0. -1 times -1 is 1 times -1 is -1. I get -2 minus 1 minus 2 equals, what does it equal? -5. Okay, so my f of -1 equals -5. Let's find our f of 1. What do we get here? We get 2 plus 1 minus 2. That is 1. Okay, and so what do I know? Well, I know that f of negative 1 equals negative 5. I know f of 1 equals 1. Guess who lives in between here? 0. Oh! Right, 0 lives between there. If I have a graph, and you're saying that at negative 1, I get a negative 5. 1, 2, 3, 4, 5. Right? And at 1, my output is 1. If you're telling me that, then at some point in between there, we're passing y equals 0. Right? We're passing the x-axis. Anytime we have a positive and a negative on a continuous function, you know that there is a solution somewhere in between those. Right? So, since f of negative 1 is less than 0 is less than f of 1, and f of x is continuous on negative 1, 1, it must be that there exists a value c such that f of c equals 0. Okay, so therefore there's a solution. Right, that's what we're looking for when we're looking for a solution. Okay, and then you would graph it using Desmos or something. I think, let me see, do I want to do the next one? Use the intermediate to show the following equations. Yeah. I think you'll be okay.